So again, this is statistics using technology, so there's a couple different ways that we can go about getting this value of R from the technologies that we have. So using StatCrunch, again, we can enter 2 columns in the spreadsheet, and we can use stat regression simple linear. In that pop-up window, we choose the X variable, the Y variable, and then click compute, and it will be in that output screen of values. Same thing on the TI-84. We would start by pushing stat1 and entering 2 lists of data. We would get into the test menu and scroll down until we see linear regression t-test. We would make our screen look like the one below. Again, depending on where you put, so again, this depends on where you put the data. So my screen says L1 and L2, but if you used other lists, you would state those lists there. Next to frequency, we still have a 1. That's the default, and we never change that all semester. And then this next line is beta and rho, okay, which now you know what rho stands for, but that hypothesis test we don't get until the next section, so that line for now doesn't matter. Okay, so this does not matter for now. But then again, next to regression equation, we should still have Y1 typed there. We typed that in the last section, so if you don't have that there, again, you can type a variables, right arrow, 1, 1. We'll put regression equation, a Y1 next to regression equation. And when we hit calculate, we have this 2 screens of output here, of which some of these we have looked at already. So we've looked at the value of A and B to give us that equation, y hat equals A plus BX. And now the one that we are looking for is this value of R. So in this case, on the screen there, R would have been 0.913. So let's take a look at the data that we have here. So if we're going to calculate the linear correlation coefficient, R, so how strong is the positive relationship between the alcohol content and the number of calories in a 12-ounce beer? So to determine if there's a positive linear correlation, a random sample was taken of beers, alcohol content, and calories for several different beers. And the data are in the table below, and we're asked to find the correlation coefficient and interpret its value. So remember, this is a data set that we started with back in the beginning of Chapter 10, but it's without the outlier. So we took out the non-alcoholic beer called O'Doul's when we were continuing with this through the rest of this chapter. So again, in our solution, if we state our random variables, so X in this case was the alcohol content in the randomly selected beer, and Y is counting the number of calories in that same randomly selected 12-ounce beer. So again, we have 2 measurements, 2 different quantitative variables on the same object. Okay, so we've got a linear regression test, or linear regression problem. So the assumptions that we need to check here, we need to have a random sample. So if we go back up to the problem states that a random sample of beers was taken. Random sample of 9, in this case, beers was taken. And the second condition, if we go back and look at the scatter plot, let's get these little markings off there, I don't know where those came from. So if we're looking at our scatter plot here, it did look roughly linear and we don't really have any outliers. So the scatter plot of the data is roughly linear with no outliers. So again, remember, it did kind of have one, but we took it out, and we didn't take it out simply because it was an outlier. We took it out because it made sense to do so, because we had a non-alcoholic beer thrown in the mix of all these highly alcoholic beers. So we threw it out based on that, and then our graph looked better. All right, so on the T84, if we use the linear regression t-test in the stat menu, and the setup for that is below. So again, if we put our data, if our data is still sitting in L1 and L2, next to frequency we have 1. Again, these next couple lines for right now don't matter for this thing, so we're just going to highlight calculate to get the output. All right, so the results from the linear regression t-test screen, we are interested in this value of R. In StatCrunch, if we use stat, regression, simple linear on those two, we have here, we also have the value of R. But again, if you notice all of these, the beginning letter here is capitalized. On here for linear regression, we're going to use a lowercase r there. So R in either case is about 0.913. So again, a number between -1 and 1 inclusive and unitless, so it gets no units. So this is really close to 1, so it looks like there is a strong positive linear correlation between alcohol content and number of calories for beer.